I ordered 3 kits from Janko, and they arrived last night. And I think I'll do the breadboard voltage regulator today. The other 2 I'll put aside. So let's take a look. I know everybody likes when you open up the kit. So it's got a nice set of instructions and description and everything here. So your part list. And what this does is produce a 5-volt regulated voltage for your breadboard. And it plugs right into your breadboard. And there's a picture of what it looks like. So let's have a look at the parts. And the parts are in another little bag. Let's put the bag aside. So what I think I'll do, get this guy here, put the parts out in there. Got all the parts. So here is our little PCB. And I think I'll show you a close-up when I start soldering this, maybe not. And you got a barrel jack. I think that goes right there, right there. Then you got an LED, you got some headers, you got a switch, you got a capacitor. Let's see what that capacitor is. Looks like 22. Let's see what it says in the instructions. 0.1 UF. That's not what it looked like. Let's get the other magnifying glass. No, I can't tell what that says. Looks like 13 MMM. I don't know. But that apparently is a 0.1 microfarad capacitor. Then we have our resistor, 1K resistor. That should be the one with the red stripe is always the 1K, and the one with the orange stripe is always the 10K. So it's brown, black, and red. And then we got electrolytic capacitor. That is 10 microfarads. And we got a MOSFET, looks like, 78MO5CT. Let's see, that's the voltage regulator. Oh, that's not a MOSFET. That's the actual voltage regulator. So that 5 at the end is probably means 5 volts. 78M05, that 5 means 5 volts. And I'm not sure what the input is supposed to be. The input voltage, but probably anywhere from 5 volts to 12 volts, I would think. Let's see what it says. 6 to 18 volts. Turn your 6 to 18 volt DC wall wart adapter into a regulated 5 volt DC 0.5 ampere supply for your breadboard experiments. So, I don't think I'm going to need too much of the instructions, but we'll look. We got all the parts. Let's see, we got 4 of these. And these go into the breadboard. And I'm going to have to find a breadboard. And so I think we got all the parts. So let's look at the next step. The resistor and the capacitor. then the regulator and the barrel jack, then the electrolytic capacitor and the LED, and then the switch and the pins which go on the underside. Of course, that would make sense. And there's a little trick to doing that. So well, I am going to follow along with the instructions, and they say to put the 1K resistor and the 0.1 microfarad capacitor, ceramic capacitor, in first. So the resistor goes in R1. And the capacitor goes in, where does it go? C2. Goes in C2. C1, C2. And I'm just going to bend the pins out a little to hold that all in place while I solder. I do have my helping hands handy. Actually, I'll attach that to there. Now I'm going to turn on my fan for soldering, which I like to use. And this keeps some of the fumes from mainly the flux out of my face, because no one wants fumes from flux in their face. So I'm using a beveled tip, a knife edge tip actually, on my soldering iron. This is a very inexpensive soldering iron that I got from Amazon, no doubt, for about $15 or $20. And this is a simple through hole, and this looks like a pretty good breadboard, a pretty good PCB. Now notice I'm not letting these things fly off into space. When I snip the legs off, I'll put them in a little container. Alright, so let's look at that. Nice solder joints. Alright, no big deal there. Alright, next it says to the voltage regulator and barrel jack. Alright, so this is the voltage regulator. And it says it goes with the tab to the tab line. So you see that white line there? That's the tab line, and this is the tab. And you could hook this up to a heat sink if you were using this with high power, but not necessary. So I'm just going to push that in with some force, and it will stay in place, and we'll hold that in place with this helping hands. Maybe we'll use two. And we'll just solder that right up. And I just want to double check. I have the tab to the tab line. All right, that looks nice. One of those little things was still stuck there. And one guy I saw on the internet suggests you get a special clipper that has a little measuring edge on it, so that when you clip the legs, they always stay the same height, and that makes a very neat little soldering work. Okay, now the barrel jack, and that is gonna go only one way that can go in. So first, I'm going to just do one little part of that, perhaps this part. Let that heat up for a little while. All right. And I'm going to make sure that's in nice and flat, which it is. And this has to take a lot of wear and tear, so I'm going to put a lot of solder on here. All right. Looks good to me. Okay, now that has rather heated up the PCB, so I'm just going to let that cool off for a second. Now, what's next? The LED and the 10 microfarad capacitor. I have those right here. The LED, the 10 microfarad capacitor has a little plus. I don't know if you can see that little plus sign. You want the long end, the long wire, or the long leg of the electrolytic capacitor to go to the plus. Also, there's clearly marked a white stripe on the negative leg, and that is the negative leg is the cathode, and the positive leg is the anode. I'm going to place that in there. I'm going to bend those legs out to hold it in place. And I'm also going to do the LED. Now it says the long leg of the LED goes in a round hole. So the negative end of the LED, right? Longer LED goes, so the anode of the LED goes in the round hole, and the cathode goes in the square hole. So I'm just going to do one side of the LED, probably the square side first. Come on, get in there. Get in there. There we go. I'm going to do both sides of the capacitor. And you want to touch the soldering iron to the wire and the pad. And then I'm gonna turn it around to make sure the LED is in nice and straight. See, it's up a little. I didn't really want it raised a little, but I'm gonna leave it like that. I'm quite content with that. So I'm just gonna solder up the other end of that LED because it looks straight enough for me. So this is a useful project. It's a real simple one, but it's useful. You just have to watch your polarities. And also there's a little tricky part coming up. Well, there's a couple of tricky parts coming up. Okay, now they want you to put on the switch and the pins on the underside. Power switch is breadboard to power switch and breadboard pins. Power switch simply mounts into the position power, nothing difficult. The breadboard pins are a bit more difficult as they go on the underside and are harder to hold while soldering. If you are confident, push the long side of the pins into the breadboard so they match the holes. Yes, that was exactly what I would have done. So first let's do the switch. Now the switch can only go one way because one side, I don't know if you can see this, the switch is right in the middle. So whichever way you put it on, I don't think it matters. Because it's either on or off. So that's going to be a little tricky to hold in place. I might use a little putty, but I think I'm going to bend these tabs out a little. And that should hold it. So I'm hoping you can see all this. Oops, we got the wrong one. Shows you how bad my soldering is. Actually, this knife edge tip is very, very workable for getting accurate because you can point it at an angle. And oh, look at that. I botched up the switch. So let me see if I can't do this way. That's tricky. A little better, not perfect, not what I would really want. I should have done one pin. There we go. All right, got it. All right, let's snip those. Okay, you see there's two little legs on the switch. Little plastic legs that press against the board. So that's on pretty good. So I'm just going to touch that up a little bit. So now the pins, so I have my breadboard here. So one thing you have to do is decide which end of the breadboard you want to use. And there's a little jumper on here. So let's say we're going to use this end with the positive on the outside on the left and the positive on the inside on the right. So let's plug the pins into the breadboard. Let's see if we can't line it all up. Look at that. Lines up nicely. Now let's just solder one or two. That looks good. And then these two are a little bit of a tight spot. We didn't want a bridge, but we'll fix that later. A short circuit is not a good thing. So let's see about that bridge. I'm just going to put a little flux on there and try and absorb that out with the soldering iron. And I'm going to get my magnifier in here too so I can see what I'm doing, which that wouldn't have happened in the first place. All right, I'm going to try the solder sucker. What is technically known as a desoldering tool. Some of us like to refer to this as the solder sucker. So Let's just get that right in there. Get that up. Oh, this is a little tricky. There's an old saying that nothing is easy. There we go. Hopefully we didn't ruin the pad. Now we'll use a little more care in resoldering this side. And that is the completed project, except for one thing. Look what I did. Now I'm seeing what I did. If you want this to be on this side of the board, the barrel jack should be pointing out. So let's turn it around. And you also have a positive and negative, a V out and a ground on the end of the board here, on the end of the PCB. So now let's see. Now, I don't know if you can see this. There are two little jumpers, actually 4. So it's telling me in the instructions how to confirm power rails. So note breadboard rail polarity is plus and minus. Right. So that means you're going to do a blob on this one and a blob of solder on this one. That's what it says, so I'm just going to follow the instructions. That one came out good. This one's a little tough to get at. Let me clear up that hole. That's good enough since I'm not going to use it for a switch. And I think I've got that shorted pretty well, or connected pretty well with a solder bob. But let's just see. There we go. Perfect. Now I got a little blob of solder on my breadboard, which I'm not happy about. So now, let's try it out. So I have a red and a blue, and a red and a blue here. So if I put in, let me turn on my power supply. Warm up for a second. So that's on 12 volts. Power supply set to 12 volts. And I do happen to have a barrel jack connected to a 9-volt connector, and I'm gonna put, let's see, I think the positive goes on that one, the negative goes on that one, the positive goes on that one, and I'm going to turn on my power supply and the light should go on, and the light did not go on. Perhaps I have them backwards. Why is my LED not lighting up? Well, maybe we got a bad LED or something. So let's get out the meter. I don't know if you can see the meter. Let's get the meter right here. You can see it. Now let's hook up red to the red. And that to that, and let's see what we got. We got 437 millivolts, half a volt. That ain't good. And that's negative. That means something is not copacetic. Let's unplug this. Let's try putting it on the other end of the board. Alright, this is a problem you most probably will run into. Let's put blue to the blue and the red to the red. And then let's plug in the power again. Now my wire came undone. Hold on a minute. Still no LED. Ah, I don't have the power switch on. There's my problem. Bingo. Now, what are our voltages showing? Negative, then we know we have it at the wrong end of the board. 4.993 volts. See that? 4.993 volts. And we do have it at the right end of the board. So that red LED, which one did they show? They showed the one on the left. They showed this one. The negative positive. So it's negative positive at this end and negative positive at this end. So that's good. So there it is. We got 5 volts coming out. We got 12 volts going in. Let's hook it up to the variable. Let's turn it off. Now I see when it's off, it's still showing voltage. Alright, now it's down to 0. Let's go variable, 4.993. All the way up to 12 volts. All the way down to 5 volts. So that's pretty good. So I'm content with that, but what I'm not content with is when I turn that switch off, I still have voltage. I have 1.2 volts, even with that power switch off. So it's possible I put that power switch in backwards. I don't know. No, it says on is on. On is to the left. So there could be a short somewhere. So let's just check. Let's unpower that. Turn it off. Let's take this and look upside down here. Check for a short. No short in the switch right there. No. No, it looks like that's what it is. That power switch. Let's look at the inside. No. Well, I really don't like that. Let me tell you. Power on. And we got our 5 volts. 4.996. Power off. We got 1.3 volts. 1.2 volts. Maybe it's a capacitor. Yeah, that voltage is going down slowly. Oh, okay, it's a capacitor. When you turn it off, it's going to stay on for a little while. So I'm not going to worry too much about that. But what I want to do is I want to test this on the opposite power rail. Now it's just showing about 1 millivolt, 1 volt, 900 millivolts. Now the opposite power rail works okay too. So there you have it. So I think that is going to be really useful. I hope you enjoyed watching that. If you can't see the 5 volts, there's 4.994 volts. So that will work anywhere from 6 volts to 18 volts on this power jack, which you can plug right into a wall socket power jack, which might go up to like 12 volts or 18 volts or whatever they are, 14 volts. They're all different. So hope you liked the video. Give me a like, give me a subscribe, and of course, give me a rumble. Thanks for watching.